This particular video is about multidimensionality, and there are several things that we will discuss here today. The concept of multidimensions, the concept of fact and dimensions. How do we create star schema? What are the key elements of star schema? How do we convert an ER model to a star schema? And then it will conclude with a couple of examples, one from the data warehouse IBM book, and second will be a case study where I will show how to create an ER model and then how to convert it to a star schema. Now, prior to viewing this video, you must have viewed or have knowledge of conceptual data modeling. You must have gone through the exercise and slides of data modeling. You must have the knowledge of primary key and foreign keys. Now, what does multi-dimensions mean? In a very simplistic way, multi-dimensions means multiple dimensions. So dimension can be treated as an axis. If you look into a graph has two axes, x and y. So we can represent two things in a graph. So we can say that there are two dimensions. If we add a three-dimension, the z-axis, we'll call it as a three-dimension. So three or more, we have multiple dimensions. So in business, we have different aspects of analyzing data, and each aspect we can term it as a dimension. We'll look into dimension in a little bit more details. The first thing we will do is to look into the concept of multi-dimension, as I can show you here. Now you see a number here. So the number is revenue, which is a fact. We'll talk about that a little bit later. But 128239 is a number. Now, it is just a number. But when we use the number on a certain context, it has a different meaning. So if we say that under the material group mountain bike revenue is 128239, then we're talking about one dimension, which is about material. If we talk about that 128239 is the sales in the month of February for the year 2010, then we're talking of the time dimension. If we talk about 128239 sales for the state of Colorado in North America, then we are talking of another dimension. So the same number can have different perspective and therefore can have multiple dimensions. We can use one at a time. You can use multiple dimensions at a time. So if you want to do that, the way we do that is we introduce the concept of facts and we introduce the concept of star schema. So facts are the focus of analysis of business activity. They are values, and so the database schema or a star schema is divided into two parts. One is called facts, that is the numbers that we need to analyze, and dimensions, which are attributes, that is context or perspective. So if we say number, a sales figure, $120, so the dimension is how do we analyze it? Are we going to analyze it by customers, by material, or time? So when we say by what, so that what is actually dimension, and the thing that we analyze is called fact. So a star schema looks something like this, where you have a fact table right in the between and multiple dimensions all around. And each of them is connected in a certain way. So a fact table must have what you see here, two measures. This means numbers, sales and profit. There must be somewhere to be measurables. In other words, I can measure product by sales, measure product by profit, or in combination. I can measure or analyze customer by sales or by profit, analyze time by sales or profit, analyze region by sales or profit, or I can combine this, that is product plus customer plus region plus time, and analyze them by sales or profit. So you can see that the whole analysis becomes very interesting when we have multiple dimensions. We have much more power to do the analysis. We can select which dimensions we want to analyze, and we can also analyze the facts, what exactly we want to do, or how do we analyze these dimensions. So that is very simplistic way the star schema. There are other ways of analyzing. There are other kinds of schema, but this is the most popular schema that is currently being used in data warehousing or we will say the most important way of storing data so that they can be analyzed. So the dimension tables are linked in the foreign key primary key relationship. We'll talk about that a little bit later. And we will see quite a few examples on how do we create the dimensions and specs and store them in a star schema. So what we will start with, we need to understand the concepts of fact tables and dimension tables. One of the important factors of a fact table, as I told you, is it must hold some numeric values. Otherwise, how are we going to analyze it? So generally, these numeric values are additive in nature. That means there is a way to additive and or sum it up. So we often use total sales or total quantity to represent facts. Okay, so now we will first show you, I'm going to show you first how to create a fact. What are the simple rules of creating star schema? Basically, how do we convert an existing entity relationship table to a star schema, and then see an example from the book, and then we'll do a complete case study. So the rules are pretty simple, and this is what I have noted it down. By the way, I should tell you now that this is an evolving topic of creation of star schema. Different data models have different ways of creating this, so this is not that the only way to create star schema. But over several years, after looking at a lot of star schema, a lot of databases, and a lot of ER models, I came up with these 7 simple rules to follow in order to do our analysis. So let's focus on these rules, and we will explain that with some examples. Now, because this is a topic that is highly practiced, so you will see that people follow these rules a little bit differently, and the star schemas look differently. The attributes in the star schema are a little bit different and stuff like that. So we have an ER model. The first thing we need to do is group the entities, certain entities and certain subtypes, and combine them. The reason to do that is we want to have very clear definitions or clearly labeled dimensions. Then we need to identify what's a fact table. That means the whole analysis is based on what? We can add a lot of dimensions, but anytime we do a dimension addition, we need to be careful, and we need to ask that if I add a dimension, does it make any sense to do the analysis? You will see some examples coming up in the case study. By default, we will always add a time dimension, because time is a very crucial way of analyzing data. We always need to know historical way. What was the sales figure or some values in a particular time period, day. The dimension tables will have some granularity. I'll talk about that. Fact tables must have measures, must hold numeric values, sales. And we also talked that this should be additive in nature. So if we have sales, we'll use the word total sales. And we'll connect the dimensions and measures using primary key, foreign key notion. So let's start by showing you an example from the book. This is in page number 54 of the book. Here, what you see is an example of a ER model. Now, it looks different than what you have seen or practiced so far several ways. First of all, you don't see any relationship. The reason being, a lot of data modelers don't prefer to write the relationship. Rather, they just draw a line. So this line symbolizes a relation. This is a relation, this is a relation, this is a relation. All the lines are relation. Now, what are these? If you remember, we use certain symbols. This is a way of saying it is one to many. X and 1 is showing that the 2 arrows means it is mandatory, and this is many. So 1 to many, many to many, 1 to many, many to many. Similarly, you will be able to see that. You see 0 here in front of X, that means it is optional. Anyway, we are not going to go through those cardinalities. We will understand that this is a simple ER model. The attributes are not mentioned here, and the lines mean relations. So based on the rules, the first thing that we will do is combine certain information. For example, you see that here we have sales region, sales outlet, and salesperson. We probably can combine all these three under the sales dimension. Then we have some information of manufacturing, region, and plant. We can combine them also. Customer location, customer can be also combined. So by doing that, we can come up with a very basic set of dimensions and fact. We'll talk about the fact later, but let's focus on the dimension. You can see already the sales have been combined, the outlet, the person, and some more has been added here. If you read the case and the book, you will see why they have added this way. Similarly, the region and plant and manufacturing, they have been combined. So what we have done is we have condensed the big ER model into few dimensions so that we can analyze. Okay, now we can continue doing that, but before we do that, we have questions to analyze. That means, how will I answer these questions based on the star schema? What is the average quantity on hand? What is the total cost? How much is being sold in this month? Who is the responsible salesperson? So we need to focus on this, and our dimensions will be guided by this. So if I've added a dimension and none of these questions address those dimensions, then probably it's not a good idea to add dimensions. In the actual world, dimensions can be added anytime because it is so easy to link with the sales with the fact table. So we can always add dimensions later rather than adding all dimensions at one point. In fact, it is very common to use more than 1,000 dimensions for one single fact and create a star schema. I already talked about the time dimension. Time is a very important component, and we need to add it by default in any star schema. And how we do that? We have a key, which is key is same as identifier or ID. So we have a time ID, then we have a date, week of year, and week of month, month of year. By default, we must have this all the time. Then we have certain rules on creating facts. Facts means how do we analyze? So here there are some examples of possible facts. Now it says that if you want to answer questions 1 and 3, then probably you can use this fact. If you want to answer questions 2, 8, and 9, then probably you use this fact. Generally, this is not the way to create fact. Facts are based on certain themes. For example, the theme could be analyzing sales, so there could be a sales fact. The theme could be analysis of inventory, so there could be an inventory fact. And I will show you some examples here. Again, they have been defining the facts, and finally, you will see here they have come up with 2 facts. One it is called inventory fact, one is called sales fact. Now, if you focus here, the last 4, total cost, total revenue, total quantity sold, and discount amount, these are the actual facts, whereas all these are actually foreign keys from other tables. Now, total cost, total revenue, why total? Because I said it has to be additive in nature, so they have to aggregate it. They have to be aggregated. And cost, revenue, quantity sold, and amount, these are all numbers. Okay, so, and the dimensions that have been used are others, as you can see in the following following figure. Inventory fact, I think this is correct, except if I have to create an inventory fact, I would not use total cost and total revenue, because total cost and total revenue is part of sales fact. So I will use reorder level and quantity on hand as the numbers to be measured, and the rest are default foreign keys from other tables. So in other words, generally using these 2 facts, we can create 2 different star schemas. So let's see the first star schema here, right here, using the inventory model. You can see this is the inventory fact, and time, manufacturing, and product, these 3 are been added. So this is a star schema because this fact is surrounded by 3 dimensions: time dimension, manufacturing dimension, and product dimension. I would ignore these last 2 because they are typically not included in the inventory fact. In other words, if I use only quantity on hand and reorder level as facts, that means I have the capability of analyzing quantity in hand and reorder level by time dimension, by manufacturing dimension, by product dimension. Okay. Now, similarly, I can use the sales fact, and as you can see, I can still use certain common dimensions, but some of them are omitted. That means the dimension that I use to analyze the sales fact, they're not exactly the same to analyze the inventory fact. So that's why you see customer and seller. You will not see customer and seller here, because there is no point in analyzing customer and seller to analyze the inventory. That means we are not going to analyze the relationship between customer with reorder level. It makes no sense, because customer is not closely related to inventory, whereas product is much more closely related to inventory, so we use product as a dimension. So we create different figures, different models, different star schemas using one fact at a time. We don't use multiple facts in the same star schema. So star schema is basically use one single fact, identify the possible dimensions, and then connect them in a certain way. Okay, so this is how it has to be used, and generally we have multiple star schemas based on different sales facts and stored in a data warehouse. So now I'm going to show you how to create an ER model from scratch. Again, this will be a practice of creating a conceptual data model, and from there, using our simple rules, how do we create a star schema. Okay, so we start with the KFC case. It talks about certain operations in KFC, what are the people who work there, how the things are developed to create different kind of products which are sold. So you have to read this case carefully before you start preparing the ERD and preparing the star schema from it. So the first thing that we do is try to come up with a list of entities, and we start with that. So the possible list of entities I have noted down here. It starts with the name of the restaurant, the customers, the walk-in customers, customers for delivery, products, gravy, salad, order, complaint, team, store manager, assistant store manager, CSA, customer service agent, driver, inventory, order, item, cooked item, uncooked item, headquarter, daily report, transaction, sales, customer, address, cash register, cash, bank, and debit card. So as you can see, the list is pretty long, and definitely some of them would have to be excluded, and we can do one at a time. We can exclude these. We have no reason to model KFC restaurant because we are trying to model only one restaurant and see what are the main concepts within that KFC restaurants. We don't need to model gravy and salad because they are a type of products which are being sold. We probably don't need to model team as well because we are talking about individual people here. Daily report. Daily report again is a report. So report is a set of information. Information is generally not modeled as an entity. The reason is the daily report consists of information about inventory, sales, stuff like that. So we can collect that by combining certain tables. So report are generally not included as entity. Transactions, will not use transactions because we will rather use some kind of attributes inside sales to capture the notion of transaction. Customer address, again, it's an actually entity attribute. It is not an entity. Similarly, cash register can be considered as an entity, but there is not much meaning here because we really don't want to analyze something by cash register. Cash and debit cards are type of payments, so probably we'll go somewhere else and will not be modeled here. So we need to talk about the scope of the model here. The scope of the model is only capturing the important concepts, not each and every concept that can be potentially termed as an entity. So that's why I ignored cash register, I ignored team, I ignored different kinds of products, and try to make it as concise as possible. Okay, we can see that there are two kinds of customers very clearly because some would just walk in and some would just call from home and they would like the products to be delivered to their location. So again, we need at least one attribute which is different from this so that we can create subtyping. So for walk-in customers, wait time is an important information. how long they have to wait after they place their order so that the product can be delivered to them. Similarly, delivery address or phone number is important. Another subtyping that could be important in this particular case is the item, because you see there are quite a few items and some of them have been cooked and or some of them are not cooked. So if they are not cooked, they have a date of expiry. For example, if I have let's say some kind of frozen, let's say just sauces, or some barbecue sauce, something like that, that will have some expiry date. Whereas something which is being cooked, let's say fries, will have some expiry time. You cannot reuse a fry after 6 hours or 8 hours or whatever the time frame would be. One important distinction that we have to make is the distinction between item and products. Item are the raw materials that are combined and sold as a product. So customers don't buy items, customers buy product. KFC makes revenue by selling products. Items are used to make products. So items are very important for them because they have to be supplied by suppliers. And that, by the way, I think I've not used suppliers here in this list. It should be added as well. So it is important to distinguish item and product because item will have different types, including raw materials, cooked, uncooked, and they will finally end up as a product which is being purchased. So product and item distinction is important. All the entities that we spoke are written in the verb stage. We need to find out the relationship and then develop the model. There is also a possibility of alternate model, which I'll talk a little bit later. Now let's go and look at the ER model that I have created based on this information, and then we will analyze. So as shown here, I have already talked about this part: customer, phone number, phone customer, walk-in customer. We already talked about item, cooked item. We already talked about an important relationship between product and item. So product is composed of items, and this is very important. So item is also related to item order, and item order is related to supplier, item is related to inventory. So you see that this part, supplier, inventory, item order, item, they are all related to items and products. Product is cooked by cook, then sales is managed by assistant manager, the deposit to the bank, assistant manager reports to the headquarter, inventory is managed by manager. This is one of the key role of the manager, is to manage inventory. So we can see the differences. We also have a CSA, which is customer service agent, and we need to distinguish customer service agent from the rest of the employees. So we have something called communication skills. Now you might wonder, how do I model it? How do I use it? As a database, if it is a database, we can say that communication skills could be high, medium, and low. So if you have a high communication skills, probably would have a very high customer satisfaction or less wait time, something like that. Driver, in order to distinguish between other employees, I have the driver license as an attribute. Sales, transaction ID. Every time a customer comes or places an order, there has to be a unique ID called transaction ID. Based on that, it will be possible to identify who placed the order, what was the order, what product was given, when was it ordered, things like that. So that's why you have the time, sales time, discount, what was the discount provided, how much was the amount. So and also you note that customer can also make a complaint, which is processed by CSA. So we have considered all the concepts. One important concept is order. Now it is important to distinguish between order and product. Order is a concept. Order is a concept because it's not a physical product. It is information about what products to be prepared. So it is not the product itself. So based on certain order, you create a product. So it has to be clear that order is different from product and product is different from item. You use item to make product. You use the information of order to know what product to make. So all these three are related, but they are very distinct. So I hope you have understood the concept of it. Item, if we have item, we also need to keep track of an inventory, how much item is left, because this is crucial. If certain inventory is low, it has to be ordered, reordered, and at any point of time, a manager should know what is the quantity on hand of all the items which are there in the store. Okay, so from here, how do we create the um, star schema? And as I told you, we have to do certain things. First thing is we will remove all the relationships. We will focus on certain aspects, probably remove some of the entities and try to combine them. For example, we can combine all the customers in one place, all items, item order in one place. Okay, probably it also makes sense to combine all the employees in one place, CSA, assistant manager, manager. By the way, if you recall, I told earlier that there is another way, alternate way of developing this, and that would be to create a generic entity called employee, and we will have employee ID and employee number, and then each subtype will have, let's say, manager, assistant manager, CSA, and driver. So that way this model will be a little bit more organized. Both of them are correct. It is up to you whichever you can use. So let's proceed on how to create the first phase of creating this would be how to create a star schema. So as I told you, I have combined the employees here, combined the customers here, and notice each one has an ID so that I know exactly how to focus on it. And here, what I'm going to do is I'm going to focus on sales. That is, our fact for the analysis is sales fact. Okay, and I'm going to modify this further. So therefore, you don't see inventory information here. Other than inventory information, what else you don't see here? You don't see here bank, right? You don't see bank, you don't see headquarter, because when I try to do analysis with sales, I have no, it doesn't make sense to put bank as a dimension. That is, analyze sales by bank. It's a very trivial information. Or analyze sales by headquarter. It makes no sense. So first step I did is I converged the employees. As you see, I have an ID only, the name, and here I have a distinction. I just don't write name, I write manager name, assistant manager name, so that when I do the analysis, I know that which name I'm referring to. Similarly, cook name, cook years of experience, driver name, driver driving license. It means that I'm talking about the driver license of the driver, not of the manager. And supplier, item I have combined, cooked, uncooked I have combined, item order I have combined, product ID, product name, product type, complaint. So what I'm going to do is I'm going to have the sales, focus on sales as a fact, and use the rest as dimensions. So next one, I'm going to focus on sales. I'm going to pull out the time information from sales and create a separate dimension. As I said before, time will be a default dimension. That's what we have here. So sales is right here. We have customer, order, complaint, customer. We all have that. And then I'm going to further organize using this as the sales fact. So this is the final figure I get as a star schema. What you will now see that you have the sales amount and discount amount. I can actually use total sales amount or total discount amount. I can do that, or I can just leave it like that. And I have done one more thing from here to here is all the primary keys of all the dimension table, which is 1, 2, 3, 4, 5, 6, 7, 8, 9. All these dimension tables I will add inside the sales table as foreign keys. So what I have done here, complaint, order, customer, sales, customer service, complaint. Okay, so customer service should not appear here because customer service is basically CSA. So this is CSA is already included here. So I'm going to just delete this. Yeah. So I have 8, 1, 2, 3, 4, 5, 6, 7, 8. 8 fact table, sorry, 8 dimension table and 1 fact table. So I organize this 8 fact table, 8 dimension table, 1, 2, 3, 4, 5, 6, 7, 8, 7, 8. And then each of them, so customer ID will appear here, customer ID, complaint ID, order ID, employee ID, product ID, time ID, supplier ID, and item ID. All of them will be included here. It also has its own ID called transaction ID. So the way it will work is either I can create use transaction ID as a primary key of the sales fact table, or if I don't have a primary key for the sales fact table, I can combine all the IDs or the foreign keys and use it as a primary key. So there are two options. I can use customer, complaint, order, employee, product, supplier, time, item, all of them together and call them as a primary key, or I can use transaction ID as a separate primary key for this table. But you can see that each table is now linked. So these are all dimensions and this is the fact. So in other words, the focus of attention for the analysis is all about sales. It would be how to analyze sales by complaint, how to analyze sales by customer, how to analyze sales by KFC employee, how to analyze sales by product, how to analyze sales by item, how to analyze sales by time. As you can see, you don't have any bank dimension. You don't have any headquarter dimension because there is no way of it makes no sense to analyze sales by bank. Now let's draw another fact table where we use inventory as the fact table, and we have product, order, item, supplier, and time. Now it makes sense to use only these because these are the things that we would use to analyze inventory. So you will have all the IDs for here, item ID, in fact item order ID should be also here. Let me add it here, order ID, item ID, and item order ID as the fact table. So all the primary key of each table will be included here: supplier ID, time ID, product ID, order ID, item ID, and item order ID together as the foreign key here. So here I don't have a separate ID for inventory. So no, I do have an inventory. So either I can use inventory ID as a primary key or the combination of all of the rest as a primary key. And how do I analyze it? I analyze by reorder level and quantity on hand. This means that I can analyze item by quantity on hand, or item by quantity on hand and reorder level, or item by quantity on hand. I can analyze it by order, or any of the combinations of this. So this is what we call it as a star schema. Now this is important because if we want to focus on a particular fact, we would be able to analyze that fact by multiple dimensions. So here we have 3, 4, 5 dimensions. So you can think that these are 5 ways of analyzing inventory, either one at a time or in combination of multiple ways to do this. So I think this is useful exercise to convert ER model to do a star schema, because ultimately the star schemas like this and this are stored in a huge database which is called data warehouse, and you as an analyst will be having an access to this. So if you remember, we talked about different kinds of users of analytics. As a business analytic user, or I can say as a business analyst, you don't need to create this. You will be provided with this. But the reason we created this so that you have an idea on how to create certain things, so that you can ask that, okay, I need another dimension. I need some other modifications on this table. But literally, you don't have to go and define this table and create this. You will be given this, and based on this, you will have to do the analysis. But a knowledge of this is very important, specifically the knowledge of how you reach this from ER model, because ER model talks about the business domain, about the main concepts of the business. From there, we get an idea about how the business runs, what are the key concepts, and now from this, we get the idea of how to analyze the business so that we are able to create very powerful analytics based on the tools that we have been given.